In the previous session, we have seen network access controls in logical access controls. And now in this session, we will see the operating system access controls in logical access controls. That means, in order to restrict the user to not to access your system, you have to have network controls, user access controls, and operating system controls. That means in these many ways, you have to restrict the user. Otherwise, logical access violation may happen. So that is what you need to understand carefully. So now in this topic, we will learn about operating system access controls in logical access controls. Okay. So see, again, this question has been asked in a different manner here. How? Operating system security involves policy, procedure and controls that determines who can access the operating system, which resource they can access, and what action they can take. As an information system auditor, determine the key areas which shall be put in place by any organization. See, already we have studied the functions of operating system in the first lesson, that is information system components. See, what are the functions of operating system? It is operating system which gives access to all the hardware resources. Operating system manages all the hardware resources. The printers, the storage media, everything is managed by the operating system. So, in order to restrict the user to use all those things, definitely we need to have operating system controls. Okay, and this is the biggest set of controls which the organization should have regarding the usage of the data inside the organization. Sir, what kind of controls ought to be made regarding the operating system? First one, automated terminal identification. That means, first of all, you should know who is accessing. That means the operating system in the server should know who is accessing the data, from which terminal the request comes. See, there will be a server in the operating system. Sorry, there will be a operating system in the server, isn't it? So, say for example, this is the server and there is a OS here and there will be many clients here accessing the data. So, now the operating system should identify from which terminal. This is terminal 1, this is terminal 2, this is terminal 3. Now, operating system should know from which terminal we are getting the data, we are getting the request. Is the terminal an authorized, authenticated terminal or not? So, that mechanism should be there to check out the unlogical access. That is very, very important. Automated terminal identification. Next, terminal login procedures. When the user initiates the logon process by entering user ID and password, the system compares the ID and password to a database of valid users and accordingly authorizes the login. That means, see, for example, I am sitting on this terminal and I just typed my user ID and password. Now, this user ID and password will reach to the server and there is an operating system in the server and that operating system has to check. It has to check my user ID and password. How do I know that I am an authorized user? Yes, operating system can easily know that because in the server there will be a file which stores all the user ID and passwords of the terminals. So, from terminal 1, whenever I log in from terminal 1, my user ID and password reaches the operating system in the server and operating system opens a file and check out whether my user ID and password are matching or not. Then only the operating system should give me a chance to access the data from the server. Then only it should give me a chance to get connected to the network. Okay. So, that is called as terminal login procedure. And the third one, access token. If the logon attempt is successful, the operating system creates an access token that contains the key information about the user, including the user ID, password, user group, privileges granted to the user. See, I will log on to the operating system, I log on to the server and I will do lot of operations. Okay. Every time I need to get connected to the server because data, nothing is there in my terminal, nothing is there in my computer, everything is there in the server. So everything I have to bring it from the server, I have to access it from the server, isn't it? So, operating system creates a thing called as access token. What will this access token consist of? My user ID, my password, okay, my user group, okay, and all other details relating to me. And it will give one access token to me. So why it is given like that? Because for the first time it checks everything. But in successive attempts, that means from second time, third time, every time if operating system has to check my validity, it takes a lot of time, isn't it? So that's why operating system follows a mechanism of creating access token. See, for the first time when I logged in into the server, operating system makes an access token to me, gives an access token to me, which that access token contains everything related to me. And for the next time when I connect to the server for some data, instead of checking all things again and again, operating system uses this access token simply. It will just look at that access token and give me the access. Means this is the shortest way of doing the work rather than checking everything all the time. Okay. So that is called as access token. And access control list. This list contains information that defines the access privileges for all valid users of the resource. When a user attempts to access a resource, the system compares his or her user ID and privileges. If there is a match, the user is granted to access. That means, see, there is a file called X in the server. And from terminal 1, I tried to access this file called as X. Okay, that means I try to open the file X from this terminal. Now what operating system do? It will first check my access token, and also there is an access control list to the file X. And what that list consists of? That list consists of the users' names who can access that file. So whenever I click to open the file X, operating system verifies the access control list of file X. Operating system verifies the access control list of file X, and it will check whether this terminal 1 can access this file or not. Okay, in access control list, terminal 1 is not there. That means that file do not get opened to me because my name, my user ID is not there in the access control list. Hence, I cannot open that file. This is the mechanism operating system will do. Okay, that is called as access control list. And next one, discretionary access control. The system administrator usually determines who is granted access to a specific resources and maintains the access control list. Then you may get a doubt. Sir, in the earlier point you told that there will be an access control list, and you told that my name is not there in that access control list. Then who actually makes that access control list? It is the system administrator, the person who is responsible for managing the operating system and the person who is responsible for all these access. So it is based upon his discretion. It is based upon his will, whether I should be given access to that particular file or not. So I tried to access file X, okay, and it is not opened because I don't have access. Means my name is not there in the access control list. Then what I have to do? I have to go to the system administrator and make a request to him. Sir, I want that file. You please give access to me to that file. Then the system administrator will look out my roles and responsibilities. And if he feels that that particular file called X is required by me, then is required to me, then he will add my user ID to that access control list. And now from my terminal, from my computer, I can open that file because my name is added, my user ID is added into that access control list. That means whether to add the user IDs or remove the user IDs from this access control list, who will have that control? The system administrator will have that discretionary power, whether to grant or remove the privileges. That is what you need to understand. Next, user identification and authentication. The users must be identified and authenticated in a foolproof manner. Depending on risk assessment, more strict methods like biometric authentication should be employed. See, generally in banks we can see there will be a small biometric device at every terminal. For example, in a bank there are 50 computers. For all the 50 computers, 50 biometric devices will be there. Okay. So, instead of typing the password and accessing the file every time, the more secure method is using a biometric. So, for example, if I want to access a file, then the system asks me the password. Then I have to put my finger on the device and automatically my finger gets scanned and I'll get access to that file. So, rather than typing the passwords, using some kind of biometric mechanism is more secured. That is what you need to understand. And you know, modern operating systems, they can handle these biometric devices also. Once upon a time, like Windows 95, Windows 98, Windows XP, those operating systems, they don't, Windows Millennium, they don't have the capability to handle these biometric devices. So that's why we need to type in the password. But right now the modern OS like Windows 10, they are having, you know, Office 365, these all modern softwares, they have the capability to access the biometric devices. So it is always advisable to use some biometric mechanism to get access to the software or to get access to the data. Okay. Next, password management system. So users are asked to have strong passwords. Okay. And these passwords should be use one-way hashing algorithms, and the password file should not be accessible to users. Means the password file can only be, it is a one-way hashing algorithm. That means your password should be coded. See, for example, someone may walk into the server room, open the server, and he may open the password file. So if you open the password file, all the users' passwords will be there in that file. So can anyone do like that? No. There should be no option of doing like that. Then how that password file should be? That password file should be opened only by the computer, only by the operating system. Others should not open it, or others cannot open it. Okay. So in that way you should design using one-way hashing algorithms. And if at all, if someone has got access to that password file and if he opens, nothing should be visible to him. Okay, nothing should be visible to him. That means the file has the data, but the data should not be visible to the people. Okay, in that care you have to take. Otherwise it is very dangerous, no? Some system administrators or some other people, they may walk into the server room, they may open the system and they may access that password file so that all the thousands of passwords of all the thousands of employees is known to that person. Then he may do anything which is dangerous to the security of the system. So that should not be there. And system utilities, you need to, when a new user is added, we need to have some software, some tools for the addition of the user, for the deletion of the user. So that also should be there. And duress alarm to safeguard users. If users are forced to execute some instruction under threat, the system should provide a means to alert the authorities. See, duress means stress. Means if someone threatens you, for example, if you do something to an ATM, if you press some button continuously, or if you make some stress on the ATM, definitely there will be a duress alarm, a stress alarm in the ATM. And that rings. And the concerned authorities may get a message in their mobiles that in this location an ATM is being under stress. So immediately they may call the local police. Some action may be taken. Like that, in our computer systems also, at the server, there should be a duress alarm. That means if a user is continuously trying several passwords, 3 times, 5 times, 6 times, all wrong passwords, he is making trial and error, then immediately a duress alarm should warn the officials. See, one person from this terminal is typing wrong passwords continuously. Then the concerned people will identify that fellow and they will prosecute him. Do you think that this system will not be there? I have seen in an office this particular system where an employee is typing the password and user ID in a trial and error basis. After 5 attempts, he got a call from the HR manager to come and meet in the office. And then the HR manager asked, "Sir, why you are attempting different user IDs and passwords?" See, how the HR manager know what I am doing here? Means duress alarm. Duress alarm. Okay? So that is the thing you need to understand. Next, terminal timeout. Means I kept my terminal idle for 1 minute. So automatically my terminal should be logged off. Okay? Especially in banking systems we observe this. For example, if the bank clerk is talking to you, answering your query, in the meantime the system is idle for 1 minute or 2 minutes. So immediately after 30 seconds of inactivity, the terminal will auto log off, automatically logs off. And again he has to put his finger and again he has to log in. This is a general observation that which we can make in banks. So that kind of mechanism, terminal timeout mechanism should be there. And even who should do this? Who will auto log off? Who will make you to log off automatically? It is operating system. That's why we are learning this point here. And limitation of connection time. That means, in an ATM, you are making a transaction. It asks you to press your PIN number and you forgot your PIN number and you are trying to recollect and it takes some 30 seconds of time. Then automatically one message gets displayed on the ATM screen. What? Transaction timed out. That means every transaction is given a specific time. In that time only, you have to finish up the transaction. If you take more time to finish the transaction, automatically the system shows a message, transaction timed out. Again, this is our common experience while using ATMs or other high security systems. So this kind of mechanism should also be there. And who will tell you the transaction timed out? Again, operating system. That's why these all things come under operating system controls. And again, application and monitoring system access control. That means, so far we have seen user access management, network access management, operating system access management in logical controls. And we also should have an eye on the applications that are being opened by the people. See, there will be many applications in our information system. Many softwares will be there. Many applications will be there. So who is opening? Okay. How much time he is using that application? What he is doing with that application? These all things we need to have an eye. Okay. So explain application and monitoring system access control in logical controls. First one, information access restrictions. That is, we should not give anyone permission to access all files. I have told you in the beginning, roles and responsibilities. What role he is playing, what responsibilities he will have. In order to discharge his responsibilities, what data is required, what applications are required. Only that much of permission you should give. See, a clerk in a HR department cannot access the balance sheet of the company. A balance sheet, the profit and loss account of the company should not be accessed by the clerks. should not be accessed by the customer. Those are internal documents. They should be accessed only by the accounts manager. What is the work to an HR clerk? What is the necessity to a marketing clerk? Necessity to access the balance sheet and profit and loss account and other important financial statements of the company? No reason. They should not access it, isn't it? So, information access restriction. That means who should access what kind of information? You should have that restriction. And second one, sensitive system isolation. Sensitive system isolation. That means there will be some high secured systems. There will be some high secured servers where a very important data related to the financial statements are there. So you need to put that system separately. You should not merge that system in the normal network. That system should be placed in a separate room, and that room should have cipher locks, and in order to enter into that room, all the necessary security mechanisms should be employed, and only the authorized persons are allowed to enter into that room and to use that system. So that kind of mechanism also should be there. That is called as sensitive system isolation. And event logging. See, this is a very, very important control. Event logging. That means, logging means recording. You have to record all the events that are taking place in the information system. That means, who is logging in, who is logging out, at what time he logs in, at what time he logs out, what he has opened, what he has typed, what he has accessed, what he has requested, everything should be logged, should be recorded. Yes, your phone is logging, no? All your incoming calls, all your missed calls, all your received calls, all the outgoing calls, they are logged. And you know, there will be some system logs present inside of your mobile phone or smartphone which you do not know. If you do any illicit or illegal activity, the police will seize your phone and they will send it to the forensic lab. Then the people at forensic lab, they will unlock your phone, even though you may lock it. They will unlock your phone and they'll open the system logs and they'll come to know what you did. Really. So that kind of mechanism we should have even in our information system. Everything should be logged. Everything should be recorded. Otherwise, in such a big organization where thousands of employees are working, how will we know who is accessing what? It is highly impossible for a human to check out all these numerous mammoth transactions, very large transactions. Every second of time, some hundreds of people will access the data. How can you check out all these things? So, as a case of detective control, you should log, you should record the activity of all the people. That means whatever you do, how many mouse clicks you did, okay, what you have opened, what you have closed, at what time you have opened, at what time you have closed, what you have accessed, what you have deleted, what you have modified, everything should be logged in. Logged in means recorded. Okay, and these logs are very important for auditing purpose. If something goes wrong, or if the information system auditor wants to check the activity of the system, then these logs are very, very important. Okay. And next, monitor the system use. Monitor the system use means what? There will be some critical systems like, the systems in the financial department, the systems in the finance department, okay, the systems in the operations department. So there will be some critical systems where from that system very important files are being accessed. So you need to have a special eye on those critical and important systems. Of course, we will have a general logs and we will have general controls on all the terminals, but exclusively on some special terminals. You need to have a special eye on them. That means you need to record each and every minute activity, and that should be reviewed all the time. Okay, that is the most important. See, for example, I am sitting on a system here, and this is not so critical system. This is a general system. But whatever I do in this system, this also gets recorded, but it is not reviewed. That means what I am doing, they may not check it on a daily basis. But on the other hand, if my system is very critical, for example, if I am the finance manager of the company and I am using a computer system, then my system is very critical because I access a lot of important information, financial information related to the organization. Then everything should be logged in, and whatever I am doing, it should be reviewed by the concerned security personnel on a day-to-day basis, on a regular basis. That is what you need to understand. And clock synchronization. See, in large organizations, the data center will be at Mumbai. I am telling you a general example. For example, my data center is at Mumbai and I have offices in different international locations. I have offices in India, in US, in UK, Belgium, Africa. I have offices across the world. And you know, due to the longitudinal differences, we have two different time zones. So now the server should know. At what time a particular file has been accessed. It has to know in IST, Indian Standard Time. See, a person from America may access a file from my server in Mumbai. So what time has to be time-stamped? You know the word timestamp? We studied it in data warehouse. So there should be a timestamp for every transaction. And the timestamp, in what manner the timestamp should be? The timestamp should be according to the local server time. That is Indian Standard Time, because the server is in India. But the person accessing the data is in America. So clock synchronization. That means you put all the clocks in a uniform manner. He may access the data from America, but that should get noted in our server according to Indian Standard Time, because we are maintaining the server in India. That means we have to synchronize the clocks and we have to put a timestamp. That is called as clock synchronization. Okay. Event logs maintained across an enterprise network play significant role in correlating an error and generating report on it. If something goes wrong and my server reports me American time, then I may get confused. So in order to avoid all that confusions, if the server can be accessed by anyone, by an African man, by a Belgium man, by an American man, but everything should be time-stamped according to Indian Standard Time. Hence the need to maintain the same clock time across the network as per a standard time. That is, as the server is in India, I have to maintain it in Indian Standard Time. That is mandatory. So with that, we have finished what? We have finished logical access controls. So in logical access controls, what points we studied? We studied about what is logical access controls and different exposures that can cause logical access problems to your computers, like bombs, data diddling, Trojan horses, salami techniques, rounding down, trapdoors, and later we studied about the network controls required, the user access controls required, the operating system controls required, and just now we studied about the application and monitoring system controls. So if there are all these controls in your information system, to some extent you can control the logical access violations. That means generally how logical access violations may happen: using operating system and using network, using user IDs and passwords. Now we learnt about controls relating to operating system and also networks and also user controls. So if all these controls are put in place in an information system, to the best extent possible, you can restrict the users from unauthorizedly or illegally entering into your system. That is the most important thing. And now, the most important part, that is managerial controls. See, developing an information system, setting up of an information system is not an easy task. It requires the top management support. The top management should initiate the development of a system, and top management should actively participate in the information system building process. And building an enterprise information system is not a short-term exercise. It is a long-term exercise. Generally, it takes 1 to 4 years, depending on the size of the organization, to build an enterprise-wide information system. It's not easy. Okay. So, definitely there should be some managerial controls. Okay. So, in this part, we will study about the managerial controls. And you know, whenever we refer to management, we should understand about the functions of management. What do you mean by managing? Managing means, for example, if you want to manage something, if you want to manage an information system, you need to plan for the information system. You need to organize, you need to staff, you need to direct, and you have to control. So, wherever you go, management always refers to these 5 activities: planning, organizing, okay, staffing, leading, and controlling. And sometimes staffing and leading comes, or organizing and staffing comes into 1 point. Here it is given only 4 points. No problem. Sometimes you can take like that. Next, what are managerial controls? The controls at this level provide a stable infrastructure in which IS can be built, operated, and maintained on a day-to-day basis. Yes, an information system has to be built properly, having stable infrastructure. Stable infrastructure means you have to have physical buildings, you need to have right kind of servers put in place, right kind of controls in place. Then who will take care of all these things? Regarding the construction of the buildings, regarding the procurement of the hardware, procurement of the software, who will do all these things? Who is responsible to do all these things? It is the top level management in the organization. And top management and information system management controls includes planning. Means, in any organization, the top level management appoints a steering committee to look into the matter of building an information system. And that steering committee consists of auditors, some technical consultants, some representatives of the senior level positions of the organization. So, by constituting all these members, a committee is formed. And that committee will look forward towards the building, operation of the information system. One more time I am telling you. See, what an organization will do? The top level management in an organization will constitute a steering committee. Okay. So, what is the duty of this steering committee? Who are the members of this steering committee? The auditors, the key people. Auditors are the key people in that steering committee. Some technical consultants, okay, technical consultants, and we have some people from users, okay, and we have senior representatives of management like Vice President Finance, Vice President Systems, Vice President Marketing, likewise senior representatives. So, by all these people, a committee is formed. That is called a steering committee. And that committee will regularly monitor the information system building process. And that committee will act as a bridge between the top level management and the users. So, this steering committee plays very, very important role in enterprise information systems. So, that is the first point you need to understand. So, it is the duty of the top level management to determine the goals of the information system and means to achieve these goals. See, at first, the first question to be asked while you go for an enterprise information system is why? Means, why should we have an information system? Why can't we simply work with basic computers? So, one important point again you have to understand here. See, in an organization, there are some computers, okay, in an organization, there are some computers and everything is done using computers. means they are using MS Office, okay, everything is done using computers, and also there is network among them, okay, but you cannot say that there is an information system in that organization. That means information system has nothing to do with the computers. That means you should not mistakenly understand that if an organization is using computers for everything, that an organization is having a network, you should not misunderstand that that organization is having information system. Information system is entirely different, and using computers for every purpose is entirely different. Even without having information system in your organization, still you can use computers for everything. See, today there is a computer everywhere. In a barber shop you have a computer, in a medical shop you have a computer, in a retail store you have a computer, in a small office you are having a computer. Computers are everywhere. But do you think that, of course there are many number of them. In a small office you can have some 15 to 20 computers in a chartered accountant office. But it does not mean that they are using the information system. Having information system means there should be a mechanism to provide actionable information to the decision makers. Means you should have that kind of softwares which takes up all the data, which filters all the data, which process all the data and give good reports to the top level management for decision making. So that is different. Enterprise information system is different. So before going to an enterprise information system, the top level management should have a clarity. See, do we really require an information system? See, right now we are using computers for everything. We are using computers for billing, we are using computers for storing the inventory data, we are using computers for payroll processing, we are using computers for delivery, we are using computers for everything. Then again, why do we require information system? Means, yes, we are using computers, but whenever we want some data, whenever we want some information for decision making, that information is not available in whatever format we require. So, for that reason, we need to have an information system setup where all the data from all these computers have to be aggregated, has to be put in one place, process it, and gives reports that are useful to us, which contains actionable information. The information which can be used by us to take the decisions. So that clarity the top level management should have. Otherwise, without having the clarity regarding why they need to go to an information system. Because they are already using computers for everything. So is information system means using computers for everything? If that is the case, already we are doing that. Already we are using computers for everything. Then why an information system is again needed? So that from there the works should start. That is the fundamental question. That is the first question the top level management should ask. Then they will find out the deficiency. What is the deficiency? Even though we are using computers for every purpose, but we could not get the data, we could not get the information for our decision making. So we want some good reports. We want business intelligence. We want business intelligence. These all computers are used for transactions purpose. But we want business intelligence. We want some data to take decisions. And that data we are not getting. So when will you get that data? When will you get that information? When you set up an information system separately, then only you will get that information. So that is the first thing. Determining the goals of the information system. Why we should go for an information system? Why an information system is required by us? This is the first question the management should have a clear-cut answer, a vivid answer. Okay. And next coming, organizing. So once the top level management have that idea regarding why they want an information system, Then they'll appoint a steering committee. And that steering committee will look after the remaining things. Okay. And next comes organizing, like gathering, collecting, and coordinating the resources needed to achieve the goals. See, what is the goal? The goal of the top level management is to have an information system, because they are having a deficiency, that they are not having right kind of information in their hands to take better decisions. For that, they want to develop an information system. Okay. So, now what they have to do? For setting up of an information system, we need to gather a lot of components. We need to gather separate software, separate hardware, people, networks, data. These are all things required for an information system, which you already know. We studied in information system components. So gathering all the required software, all the required hardware. Again, please don't ask me. So already we have hardware, already we have computers, already we have software. Again, why we need to gather? That is what I am telling you. Information system is different. You are having computers only for transaction purposes. Whatever computers you are having right now in your organization, they are helpful only for making the transactions, but not to the top level management in giving reports. So now we are having a separate system, we are having a separate software, separate hardware, separate data, separate people to give information to the top level management for decision making. So that is different and this is different. Of course, we will take data from these transactional systems only, but we will process it separately. Do you understand? That is information system. Okay. So for information system, what we have to do? We have to gather, allocate, coordinate all the resources. All the resources means software, hardware, people, data, networks. These have to be procured. So that is called as organizing. Who has to do all these things? Again, top level management or the steering committee appointed by the top level management. Okay. Next, leading, motivating, guiding and communicating the personnel. See, if you want to have a separate information system, you have to write programs. Okay, you have to write the programs. And I told you, setting an information system in a large organization like railways. Okay, and you know, railway is undertaking a very big project called an ERP system. Railways are implementing an ERP system. Okay, Indian Railways 1, the name of that system is. Okay, for that, you know how much they are spending? 60,000 crores. And do you know in how many years it will take to complete that project? 8 years. That means railway is a very big organization having different zones like South Central Railway, Southern Railway, okay, Eastern Railway, Western Railway, and again these zones are divided into regions. So in order to make an information system by joining all the systems in all the railway stations and getting the data, accessing the data, processing the data, to make a separate information system, okay, it is spending 60,000 crores and it is taking 8 years of time. So definitely some motivation, some leading is required because the projects may get delayed. See, what is my goal of having an information system? I want to have an actionable information to take better decisions. But building that information system, if it takes a lot of time, if it exceeds the stipulated time, then I will lose a lot of things, isn't it? I may not, if my information system do not get completed in the stipulated period, then there will be cost overrun, time overrun, and meanwhile I lose a lot of things. So that's why all the information systems, they have to be planned properly and they have to be done properly and everything should be done in the given time frame. So that is what is controlling again. So this controlling and leading happens at the same time. That means the steering committee, which was appointed by the top level management, they have to continuously monitor whether the information system building process is continued properly or not. Okay, is done properly or not. If in some areas it is not done properly, then you have to motivate the people, you have to lead the people, and you should make them to work on time. Okay, so this leading and controlling takes like that. Top management must prepare two types of information system plans for the information system function, a strategic plan and an operational plan. The strategic plan is long run in nature and operational plan is short run in nature. See, EIS is again a very big word actually. Okay, EIS is actually a very big word. See, to have an enterprise information system, you need to have a market information system, sales information system, customer relationship management system. Okay, you need to have a financial management system, accounts information system, office automation system. So, a marketing information system plus sales information system plus CRM plus FMS plus AIS plus OAS plus many other systems. All these information systems put together, it is called as enterprise information system. That means you have to start work first to build these systems. Do you remember the definition? An information system is a collection of several subsystems. Now, enterprise information system is the main system and these are all subsystems. First, you need to start work with the subsystems. See how this body formed? First, slowly organs formed. And when all the organs formed, in the later months, the skin forms. Likewise, first of all, you have to develop the subsystems. Now, the top level management has to have a plan, a strategic plan and an operational plan. That means, immediately what subsystem is very important to us. Generally, for any organization, financial management system and accounting information system or the immediate systems that are required. So, they need to start work with the accounts information system and financial management system. First, they should build these two. And later on, slowly, see, information system is not a silly affair. It requires a lot of money. See, Indian Railways is spending 60,000 crores. But for your organization, it will be at least 10% of your annual turnover at least. So, you have to spend in a lot of money. So, that's why the organization should have a long-term plan. That means, initially what information system we should build. First, we will start with FMS. And later, we will add accounting information system. Later, we will add marketing information system. Later, we will have customer relationship management system. Later, we will have office automation system. So, you should have a priority, you should have an order, and accordingly, you should spend money and build the systems. So, when will an EIS be in place? When will there be EIS in your organization? When you have all these systems built. That means, if you start your work today, that is in 2020 September, it may take 2 to 3 years, it may take 2024 for the work to get completed, to have a complete enterprise information system in your organization. Because first of all, you have to build these all systems and then you have to join them, then it is called as enterprise information system. Okay, so the top level management should have this clarity, where to start the work. See, for example, first you started the work with sales information system, which may not be very essential. So, you will lose money and you will not get the benefits instantly. So, you have to think from where to start the work, which system should be developed first, later on which system, later on which system. How to complete this enterprise information system project, where to start the project, where to stop the project. See, for example, a metro train is constructed. In Hyderabad recently, metro train project completed. First they started the line which is having more demand in phase 1. Later on in phase 2, the line having less demand comparatively. And in phase 3, the line having much less demand. So, you should, in that way you should complete. See, there will be metro project completed in Hyderabad in different phases. Likewise, in our organization also, we have to build an information system in phases. building an information system do not happen all at once. So, and top level management should have a strategic plan and an operational plan for that. Next, explain systems development management controls in managerial controls. See, system development management has a responsibility for the systems concerned with analyzing, designing, building, implementing and maintaining the information system. That means this steering committee again appoints another subcommittee regarding the systems development. That means how the system development should start, isn't it? First of all, we decided that we should have FMS, financial management system. Then how that system will be developed? Now in this question, we will learn. First of all, system authorization activities. System authorization activities. That means there will be many departments in our organization. So we will ask all those departments to send their proposals. See what kind of system you are looking for. We will ask the finance manager, sir, what kind of information system do you want to have? What problems you are facing right now with these computers? What betterments you want? What options you require? We will ask him. Likewise, we ask the marketing manager, we ask the sales manager, we ask the accounts manager, and they'll send us the proposals, okay? And now, user specification activities. One thing you please remember, whenever you make a proposal for a system, you should actively involve the end users. See, who will use the system? For example, the finance manager uses the system, finance management system. The accounts manager will use the accounts information system. So, whoever uses the system on a day-to-day level, you should involve them because they will give you valuable feedback. They will give you valuable suggestions and information regarding how to work with regarding the system. So, you should actively take feedback from them, and you should think, okay, now the finance department, they sent a proposal, and now you should think, the technical team, in steering committee some technical people also will be there, I told you. So those people should sit and think, okay, if the finance department requires this kind of information system, what technology we have to use, what will be the cost of the technology, okay, what will be the cost of software, what will be the cost of hardware, what will be the cost of network, okay, is it possible to satisfy all the requirements of the finance department, okay, this is all very, very important. You know, the organization should not work as per the system, as per the information system, but the information system should work as per the organization. That is very, very important. That means we should devise an information system in such a way that organization people should use it happily. On the other hand, if you build a system without consulting the finance people, you directly made some system and has installed in the finance manager laptop or in the finance manager system. And if you give him some training, you should use like this. Then if he asks a doubt, sir, how to get that report? Then this fellow is saying, no sir, you will not get that report. So that should not be the case. It should not be like that. So that is why you should do it in a reverse manner. First you take the data from them, you take the feedback from them and try to build a system. Try to build a software. See, information system means software, Nana. So try to build a software which satisfies their requirements. Okay? And now internal auditor participation is very, very important. Now, because it is the internal auditor who gives suggestions about the controls to be put in place. Especially the financial, see, every information system, some way it is related with the financial statements. And wherever there are financial statements, there will be our auditor. Our auditor sir will be there. So, this auditor should be a key person in the steering committee. to give his valuable suggestions regarding the controls. Because you should not build information systems without proper controls. So, who will know, who will have a great knowledge about controls? Auditor. He has studied a subject called auditing and assurance. He knows what kind of controls, internal controls that are to be put in place. So, you need to consult the auditor also. And you have to build the software and you have to finally test the software thoroughly, okay, to identify any errors in the software. So, this is how a system is built. How the system is built? First of all, we will ask the people to give their proposals, okay, and please remember that users should be actively involved. We will take all the reports and feedback from them, and our technical team will sit and will try to design the system. And don't forget to consult the internal auditor. You take his suggestions and controls from him and try to develop a software information system and test it thoroughly. So this is how, simple, in a broad manner, this is how an information system is built. And the final one is user test and acceptance procedure. See, it is not the test of the technical people, but it is the user's test. That means the real users who use it in day-to-day life, they have to use the software and they have to accept. Then only the system building work stops. They have to test it finally. So get it tested by the users. Okay. And once users are satisfied with the system, then that system is accepted. Okay. So that is the most important thing. Next, explain programming management controls in managerial control. See, what did I tell you? Information system means mainly programming only. Information system is software. Okay. So programming the software is very, very important. You need to have right kind of programming languages selected. You need to select the right kind of language. There are many programming languages like Java and recent programming languages like Python, Scala. Okay. And first of all, we need to make the right kind of programming language. And again, there will be a process called as PDLC, Program Development Lifecycle. That means how to write a program. First of all, you have to draw the flow charts. Okay. You have to draw the flow charts. You have to make the documentation. Okay. And then you have to write the program. So there will be a specialized procedure called as PDLC, Program Development Lifecycle. So we are going to learn about that program development lifecycle. First is planning. That means we need to have a plan towards how to write the program. At what time the program should start and at what time the programming should stop. For that we use some special techniques like PERT charts, work breakdown structures. Okay, PERT chart means project evaluation and review technique. That because we are writing very big programs, no? So that's why that program is divided into modules. So what should be the start time and ending time of each module? Whether we are following the timing or not, constantly we have to check. Otherwise, you know, information system is a very costly affair. If you don't follow this in a very strict manner, money gets wasted. So we need to all the time control. That means what? Controls should be exercised to ensure software released for production use is authentic, accurate and complete. What do you mean by software released for production use? Production use means real-time use. That means these people will write a software and release it to the users to use it. That is called software released for production use. So that care you have to take. Next, design. You have to select the software design approach. Generally in software design, there will be two technical things. We can write software based on some structured design approach. Generally nowadays structured design approach is not followed. Nowadays object-oriented design. We studied object-oriented database models and they are mainly used right now. So today Python, Java, VC++, .NET, they are all object-oriented languages. So generally we select them. And also programs can be written in top-down approach or bottom-up approach. These are all different styles in programming. These are all technical things, but the steering committee, there are technical people, no? They will know all these things. So they will take care of all these things. And again, a very, very important thing, that is testing. See, once the program coding is finished, you have to test the code, you have to test the program. You have to test it unit-wise, integration and whole of the program. That means, see, information system means very big program, very large program. It is a very large program. Okay. So, as this is a large program, this program is divided into modules. So, first of all, this module 1 is written, later module 2, later module 3, module 4, like this. So, you have to do the unit testing. First, you test this module, whether it is working fine or not. Later, you will test this M2 module, whether it is working fine or not. So, this is called unit testing. And again, you have to do integration testing. See, once module 1 is separately developed by a separate team. Module 2 is separately developed by separate team. This is developed by team 1, this is developed by team 2, and this is developed by team 3, like this. So, you have to test them individually, that is unit testing. And later, you have to join all of these things. Okay, because these are all modules related to the same program. That means, our financial management system is divided into 3 modules and 3 separate teams have written this software. Now we have to do the integration testing. Whether all these 3 modules, if they are joined together, are they functioning properly or not? So first individual testing, later integration testing. Means the integration is done properly or not. And again, at last we have to do whole of the program testing. That means once they are joined together, is it okay? Are they functioning properly or not? Again, we have to check. That is called whole of the program testing. Next, operation and maintenance. You have to carefully do the operation and maintenance part. See, once the information system is in use, some repairs will come, some files will be missing or some problems will arise. So, you have to do repair maintenance. And sometimes you need to update your softwares, you need to upgrade your softwares. Okay. So, that is called adaptive maintenance, and all the time you need to run the antivirus programs, you need to run the firewalls to keep the software intact, to keep the software functioning perfectly. That is called as perfective maintenance. So, this is an ongoing process, this is an iterative process, means happens all the time. Repairs may come at any point of time, and you need to update and upgrade your system, and you have to make every effort to keep your system perfect. So, these all things are to be done. So, that is the programming management and control. Okay, right.